We're going to go ahead and move on to the eye that gets welded onto the end of the new rod here. So this is a piece of material that I have. It's an 1.25 inch ID by 2 inch OD DOM tubing, and we're going to machine that out, part a piece off, and we'll drill and tap it in the mill and screw it onto the end of the rod there and weld it on. Okay, so let's go ahead and get going. So this end of the tubing I've already used for something. It was bored out and then cut off in a bandsaw, but this counterbore right here is right at the size I want to finish this at, so I'm going to go ahead and utilize that. So since we're going to turn the OD, I'm not really going to worry about what the run out is in relation to the ID and the OD. We're just going to indicate that part that I've already machined and just kind of touch off on it. And my finish length is going to be 3 1/8. So 3 1/8 to be about, right there. So you give yourself a little room for your tooling, of course. That should be pretty good right about there. I just preset the chuck for 2 inches. And we're going to use my Starrett ID attachment here. This is the Starrett number 670. Just making sure y'all can see that. Pretty dang close right out of the gate, huh? Oh, wrong way. Okay. That's about 1/2 thousandths of movement. That's good right there. Let me just double check all the jaws and make sure they're tight. And I think we can work with that. Got the ID finished out. I'm going to turn the OD down 1/8 of an inch. We're going to finish it at 1 7/8. That's just a 16th that I'll measure and make one more pass. We're running 420 RPM, and that's a 10,000 speed rate. So here's one of the little self-challenges that I do with myself quite often, and I think anybody that's a machinist does this kind of stuff. So what I want to do, I'm going to scale this thing out where I want to part it off at. Just scaling it, and after we part it off, I'm going to measure it with digital calipers and see how close it is to the actual line of the reading. So I'm going to be reading 16th. I want to finish this at 3 1/8. I'm going to part it at 16th long, and we're going to go over to the 3-jaw chuck and face the other side off and chamfer it. I did this today at work, and to my surprise, I was exactly on the correct width, exactly a 16th. So we're going to do it again here in my shop today. I hope I gave myself enough room there. So what I want to do is line it up with 3 3/16 to the edge of that tool bit. Come on, man. I got the shakes today or something. I like to say, and I learned this from another machinist a while back, is that a good machinist can read a scale within 10 thousandths. And I'm not talking about the graduations that read that fine. I'm talking about like a 16th to 1/8 of an inch line, just a regular line. It doesn't even metric, guys, 10 thousandths of an inch is well within reason to line up with an edge of something. All right, so I'm going to keep it right there, and we're going to go ahead and part this thing off, and it should be approximately 62 thousandths longer than the finished size that I want. Alrighty. There's our parted off piece right there. So I parted it 3 3/16, so it should be 3.187. .187. So of course it depends on where you wiggle it. I'm not pushing in real hard, but so I would say that I'm within 1/1000th of what I wanted to part that off at. So here's one of the benefits of having two lathes that you can rely on. You got one that you're doing your part on, you're machining your part, and then you got a second op like this where you want to face it and chamfer the other side. That's something that I like to do just about any time I can to make my parts match on each end. I don't particularly like the finish of a parted end, but I mean, sometimes it just depends on what you're doing. This, I want it to look nice. So I go to the other lathe. We got this 3-jaw set up. I'm not worried about what the run out is. We're gonna face it. And what I'll do is I'll just face it and measure it. That's not a super critical link, by the way. I wanted to take a minute and show you this new tool that I got in from Edge Technology. So what this is one of the speed handles for the Kurt vise here, and one of their newer products that they started selling to the public there. They sent in this, and they got some other newer stuff too as well that they sent over there to Stan for the Bar Z Bash as giveaway items. So I want to go ahead and pull this one out and check it out for the first time. I've always wanted one of these little speed handles, and I've never bothered making one, never bothered picking one up, and this is a nice addition to the shop right here. So let's check it out. The model 50-000, size 3/4 inch. That'll be 3/4 hex for the Kurt style vise. So it's actually it's casted aluminum. That's what it appears. It's cast aluminum. So they got a thumb screw there on this end so that you can lock it down onto the hex. And they've gone in there and machined the hex out right there. All right, so you got the middle one so that you can move the vise really fast. It's tapped there so you can move this set screw over there to that one, and then you can move it to the outside so you can get more torque if you need to snug it down a little bit more. All right, that's pretty nice. I'm going to enjoy having that right there. So nice new tool from Edge Technology. We're going to make use of it on this job right here where we're going to set up our piece for our hydraulic cylinder and do our drilling and tapping that we need. So we're going to do a couple little setups here. Got some parallels we're going to put in there. All right, we got our eye. So we use our little speed handle. Move it on out here and give it some torque. All right, and you can, I guess, just move it off out of the way if you want. I'm going to go ahead and use this vise jaw stop up against it because I'm going to drill through. I'm going to have one hole that's drilled and tapped to screw it onto the rod, and then the other hole is going to be for a grease zerk. So I'll drill through, and then once I'm through tapping one side, I'm going to roll it to the other side, line it up with a drill, and then have it in line for tapping. All right, just use the readout there and use the half command. And now we're in the center of our piece, both axes. You're going to be drilling and tapping for 1/4 20. So what I just realized is that one side I was going to do 1/4 20 and the other side's 1/4 28. If I would have thought ahead, I probably just would have made everything 1/4 28, but since a 1/4 28 uses a larger drill bit, I'm going to go ahead and drill this hole out with a number 3 drill. Okay, and then now what I'll do is go back in there with our number 7, which is our tap size for a 1/4 20 bolt. I'm going to go all the way through. That way I want them perfectly in line. You come down and you just take it easy and let the drill try to start itself. All right, there we go. So what I'm going to do is, instead of power tapping it, we're just going to do it by hand like this. I just brought it down so that the tap will grab it. All right, that should be plenty of threads there. So we'll go ahead and flip it around now. That's the reason why I used the little vise stop there, is that I have 2 points of reference to make sure that it's centered up. And we're going to use the number 7 drill bit. Alright, so it's in the hole and it's up there, so it should be pretty well squared up with the hole that was drilled. And then for that I'll use a 2-flute spiral pointed tap, or also known as a gun tap. There's the bolt we're going to use. Just kind of screwing it in freehand. I'm going to mark it to cut it off, so I know that we're a little over a 1/4 inch wall thickness on that, so I'm going to paint it back here at the 1/4 inch mark, and we'll cut it off there. Alright, let's try this again. Okay, good. We got clearance in there now. So I'm going to go ahead and ring it on there. Alright. Now sometimes you can, on the big ones, I'll take a soft blow and bump it just to kind of snug it up. So doing that allows you to fixture an eye on the end of a rod, and it's not moving around. You're not having to hold it on center. You can tack this thing off and it's going to stay nice and square and where it's supposed to be. So next step is welding it together. Alright, we're set up to do our welding. I'm going to stick weld it using some 7018 Excalibur rods. And I've got the ground hanging on the end down here. It worked real good. The cardboard tube, and I soak it in water down this end. That helps keep it from burning, things like that, and help protect the chrome from spatter. So I'm going to go around it with a 3/32 rod, get a bead all the way around it. Then I'll go in there and I'll fill it in and make sure it's all filled in good with a 1/8 diameter 7018, and I'll just rotate it by hand like that. First bead down never is really pretty. You're just trying to get it, you're just trying to fuse it in there really good. I think it's time for a new brush. I'm going to crank the amperage up some now. What I'll do is I'll probably go at least halfway around, and then I'm going to stop and chip the flux off so that I'm not having to try to blend the start and the stop together with all that flux in the way. I stop, knock it off out of the way, and then run the other side of it and then fill it in. So I'm using these old Excalibur 7018s that were given to me, and they're doing just fine. And I bend them like that so that it puts it in a more comfortable position to weld in. Like it's filling in pretty good. So everything's cooled down, and I went ahead and polished it up some, got it cleaned up, and we got one more little piece we need to make, and it's got this little cover plate that probably cut out a piece of tubing or pipe here to protect the greaser from getting hit or damaged and broken off. So I found this piece of tubing down there in my stock. I'm going to chuck this up and just real quickly part me a piece off, and then we'll stick it over the hole there and get it welded on. Alrighty, that'll work. Just got the weld on each side to hold the tube there. So on the piston, we've got to make a modification. There's your piston there, and the original seal is this style right here, which is a PTFE. So you have your seal, and then you have a rubber expander that goes underneath it there. And usually when you take these out, you end up messing them up and breaking them. So that's what that is there. That's just me getting it apart. So this particular seal, which I believe is, let me show you right here, a PS 1400, they don't make that in this groove size for this piston right here. And this is something that we run into quite often in the hydraulic shop. So you have to kind of go through here and pick out the best choice for your application and just machine the grooves to fit a different seal. As long as you got material there, you can machine it wider and deeper, you're good to go. So I'm not gonna use this particular one. There are a few other choices right there. You have, this whole series of PS type seals. That is the glass filled PTFE. You have a bronze filled PTFE. But my favorite ones to use is the PS 2700 right here. Glass filled PTFE polyester piston seal with a rubber expander, so it's good for 5,000 psi. And now the one drawback is it says 3 foot a second, and some of these others up here, you know, you've got 12 foot a second. So if you've got an application where you've got a cylinder that's moving very fast, then you're going to have to make a different selection up here. But this particular cylinder is just an outrigger for a tractor, so there's nothing wrong with a PS 2700. So this is the one that I got right here, PS 2700-40A. I found that in the book. So I've got the dimensions in there, and we are going to modify this piston. Go ahead and cut it open and we'll check it out right here. So there's your seal, and then you got your rubber expander that goes down in there. You can see our groove is not wide enough, and also the depth needs to be changed as well. So we're going to modify that to fit that seal there. And the other thing that I like about this style right here, the polyester, is that it snaps into place very easy. This yellow type right here, this other style PS seal, they expand very easy, and then whenever you get them into the seal groove, they're kind of like sticking out. You got to use a piston seal tool to kind of like clamp around it and squeeze it back into shape, where these red ones here, you don't have to do that. So anyway, enough talk. Let's go to the lathe, modify that groove so that we can install this seal. We're going to use our 3-jaw again, and that's where a chuck like this again makes things real nice and easy, a little bit faster. Okay, quite a bit. Now this is a pretty good application to use those little rollers like John Mills Double Boost uses, but you see it doesn't take much to get it bumped in true. It doesn't have to be dead nuts, but you know, we like it as close as we can get it. So that's a thousandths right there. Let's see if we can. It's tough to get that little bit on the 3-jaw. Let's see what our OD is, just for fun. Now keep in mind there's going to be wear on this piston. Alright, so I'm getting, that's less than 2 thousandths total. The tool I'm going to use today is the Sandvik T-Max Q-Cut grooving tool. And this is something that I picked up on eBay here recently. Got a really good price on it. I think I paid like somewhere between 20 and 30 bucks for that tool. And the reason why I got that, the insert there, this is a pack of inserts that I had got from a viewer, and I don't recall what viewer had given this pack of inserts to me, but I didn't have the proper tool to use them, so I finally picked one up so that I can put these inserts to use. That's the same style that I use at work a lot, and they work great. So we'll focus on the width first, and then we'll do our diameter. So that tool is just narrower than the width of the groove that's been machined in there, so I'll just center it up visually there, and I'm gonna preload my dial over here, my indicator. So we need to take a total of 154 thousandths on the width to make it the proper width. And since I've centered it up, I want to kind of go equal directions. So you divide that in two, that's 77 thousandths. So we'll move it over 77 that way. I'm just going to go down until it touches the bottom. Alright, set my 0 there. We'll go back to our 0, and then we'll go 77 the other way. 50, 60, 75, 67. And what I like to do is just touch it like that and hope that I'm right. And we kind of come in here like this. It's 269. I'm not measuring it all the way over. Okay. Let me go in there. All right, so I might have to take, yeah, we're about, that's 4, 5, 6, 7. We're about 6 thousandths narrow. That's okay. Let's go on in there to the bottom, and then we'll re-measure it. I know why now. I didn't, what I did when I figured that math, I was figuring the width of the groove, which was 130 thousandths. So that's where that 6 thousandths is. And I was just offsetting from the width of the tool bit itself. So it's a little thicker on this side, so I'm just going to take it off there instead of splitting it. So, yeah, 4, 5, 6, 7. Let's go another 7 thousandths. 2, 3, 4, 5, 6, 7. All right. I'm going to set a 0 there. And we're just going to go across and skim the bottom. Okay. So now we're going to do something different. So these are those groove mics that I got from Shar's. I'm sorry, groove calipers. These are the Aventor calipers like I've been using. So you can use these to measure OD grooves, and this will be a good caliper to use to measure this piston groove diameter right there. Okay, you can get in there and measure it. So what we'll do though, we'll go to our 0, and our diameter that we want is going to be 1.962. So we'll just come out here to that figure. Okay, now what we'll do is we'll 0 it right there. That's going to be our diameter that we want to finish at. So then now we can come over here to our piston and just get an easy measurement there. That's telling us how much we got to take out of there. So about 141 thousandths. And you just cut it until you bring this back down to 0. Let's go ahead and do 100 thousandths and then measure it and see if we're close. Now that tool bit can take a little bit of side cutting, but I only use it for a very light amount. You just skin the bottom of it once you get it down to where you want. All right. So that should leave us about 40 thousandths to come out of there. I was getting 39.5 on the calipers when I'm in here. There's 38. It's 39. So we're very close to what we wanted there. And you do have a tolerance on these grooves here. So you ain't got to hit it dead nuts on. I mean, if you're a few thou under, it ain't gonna hurt anything. I went in 39. I'm gonna feed it across. All right, so we're minus 0.02 on the groove diameter where I wanted it there. All right, so that's well within the tolerance that they give us in the book. We're gonna go ahead and start putting the seals and everything. I like to grease everything up to make it easier to install. There's your rubber expander. And then this will just should pop right on there. There we go. We have a small O-ring, 0.22. I can't grab it because my hands are greasy. That's going to go right there. That'll seal the threads of the rod. All right. All right. Now we got our gland. I cleaned that up just a little bit. I cleaned the face up some and a little bit on the OD just to kind of get rid of the burrs. So here's our new rod seal right here. That is a loaded rod seal, a bead designation. It's got the little bevels on the corners there. So there's the old rod. The old rod seal, I mean. It damaged from me getting it out, but it was bad. There's a new one. These are a little difficult to get installed just because you have so little room to work with, and that rubber expander makes it a little bit harder to get in there. So let's see if we can prevail and get it where it needs to be. They do make tools that you can use to kind of collapse these things and put them in there. I don't have any, and honestly at work we don't even really use them either. I got the end of that ground off there so it doesn't cut. There it is. Popped into place. Just a little tricky to get in there. You got to be creative with it, but you can get it in there. Just don't go in there with anything sharp and pokey and mess the seal up or the cutting edge up. All right, here's our wiper, our rod wiper. These are usually pretty easy to snap in place here. Just like that. Alright, on the OD of the gland here, we have, this will be our tube seal, O-ring and backup, and then we have this O-ring here. Get a little bit of grease on it. This goes down over your threads all the way up to that shoulder, and that just helps seal the moisture, water from getting down inside there. See if we can get our backup on there. There we go. And then our O-ring. Back, the O-ring to the back. There we go. Our gland is now ready to install. All right, now we're going to go with our piston. We got our O-ring on there. Actually, let's just go ahead and slide the O-ring up That way it's not trying to squeeze on those threads, and then it'll pop into that groove. There it is. All right, we're ready to put it in the barrel. I've cleaned these threads out right here, and I inspected the bore, and there's no scarring or scratches in there. So the bore is good on this cylinder. So we can just shove it in there and usually kind of walk it in some. There we go. Come on, baby. I'm going to put just a little bit of grease on those threads there. Getting up on that O-ring now, nice and tight. Should be plenty tight right there. All right. There we go. We have a finished rebuilt cylinder, guys. All it needs a little bit of cleaning and painting, but I'm going to leave that for Fernando. He's got to have a little bit of fun with it. We got the grease zerk in there, so this is ready to go. Thanks for watching. I hope you enjoyed the videos here that I brought you, and we're building this little hydraulic cylinder. And you know, showing you things like this is my way of showing the guys that haven't got into jobs like this that it's really not too bad, but you definitely got to have the proper tools to do it. You know, you need to have the proper spanner tools to remove glands and things like that. But not all cases you got to do machine work. A lot of times you can just take these things apart and identify the seals and put new seals back in them and get you back going again. Okay, so these are very common, these types of cylinders right here. These are very common. So even if you just invested in some ring spanners, some hook spanners, and some adjustable face spanners, if you have cylinders, that'll get you by for a lot of jobs there. So if you need seals, you can take your seals off and go into a hydraulic supply store, and they will help you identify them and sell you what you need. They usually don't cost a lot of money. So anyway, we're gonna go ahead and end this. This is one job done, and Fernando is very happy that I have got him a fresh cylinder to put back on his tractor, and I was very glad to help him out because he helps me out a lot. He's done a lot of things for me, and that's what we do. We help each other out whenever that time comes. So hope you enjoyed the video, and we'll see you on the next job.